Hello everyone, thank you for attending this webinar, which will be with a quite new format today. We were used to explain features about IPSDK Explorer, but today, so we are starting a new format which is more dedicated to the way of using that and will be focused on our new way of promoting the product using plugins. So I will explain you what plugins are. The microphones are muted, and well, you are well known about that. And you can, anywhere at any time, you can ask questions, and I will answer that at the end of the presentation. And if after the presentation you still have some questions, feel free to contact me. So I am Joseph Batista, working for a reactive IP company, and most of you already discussed with me in the past. And well, I'm a quite old guy in image processing, but well, I will let you know about that. So just a few words about those who are not familiar with reactive IP and with IPSDK Explorer. Reactive IP is a French company founded 12 years ago, so we are not a newcomer in the market. And we are based in Grenoble, in France. If you don't know, or if you are not familiar with French geography, Grenoble is in the Alps, and it's close to a famous scientific place, which is ISRF, so the European synchrotron. We are just a few hundred meters far from ISRF, and we rely on more than 20 years of experience. Myself, I just celebrated my 20th anniversary in image processing, so that's why I can say I'm quite an old guy in image processing. And you may ask, why did you create another company for image processing or image analysis? There are already some in the market. So the main goal, the main thing that motivated the creation of the company was to offer a fast and optimized image analysis solution that can be used by any type of users, going from pure developers that want to integrate and that want to be using IPSDK in Codeline, so integration in their own process or in their own software package. And well, for these persons, there is no real need about a graphical user interface. But we also have some what we call end users, scientists or industrial actors that don't really care about the way of implementation. What they are interested in is getting nice results. But they want to get those nice results in an easy way. But at any time, they may be able to criticize or understand what's the mechanics, what's the engine behind the results. So that's why also we created these plugins. And in between, you will have all the what I call geeks. I don't know if it's the right wording, but I am myself a geek. Being a geek is not a bad word. People that do like to be experimenting things, that want to check all the button functions, that want to understand what's behind the scene. And so we have the access about all that. So we really have these three type of profiles. Of course, there are much more profiles and much more type of users. Any user is a different profile. But so we wanted to propose a performance solution for all these type of users, but also for any type of image acquisition device, which can go from optical microscopy, electronical microscopy in 2D. But it can be also electronical microscopy in 3D, like in FIPSEMS or like in Tomo TEM. But it could be also in X-ray 2D or X-ray 3D, like in tomography. Now we also have access to 4D analysis, 3D plus time. But there is also thermal images, neutron sources, multi-channel, multi-energy. So the idea is really to propose a versatile tool that can answer to all these type of techniques. And as a company, we are experts. We are quite old in image processing. So we have plenty of experience in image processing. And the idea is that you can really focus on your own research, on your own industrial application. And you can rely on us to translate your human words into algorithms. Let us build for you. Let's just subcontract us all this creation, all this image analysis thing, and so that you can really focus in the results and understanding the results. We propose some software through a library or through the software package with graphical user interface. We also propose training that can be adjusted to the level that you want, which could be workshops, basic trainings, understanding what image processing is, but it can also be very advanced trainings on coding or on usage about your own application, because we can also develop some customized applications. Translate your process, your human process or your scientific or your industrial process into scripts. We can do that for you. We can also integrate your own scripts. If you already have some scripts or if you already developed some interesting algorithms, we can also integrate them inside IPSDK. I said IPSDK is fast. This is one of the graphs that illustrate that. You can see IPSDK in blue, ITK in red, and image in yellow. And you can see that for the same computation, the same result, IPSDK is between 20 to 25 times faster, which will permit you to increase the number of analyses that you can perform in the same amount of time. But you can also, thanks to that speed, you can also address much more time-consuming, but also much more precise algorithms. One of the well-known algorithms like this is the non-local means, which is very time-consuming, but it's a very nice filter, edge-preserving. Most of the time, it's not possible to use that on big data sets because, well, it will make too much time of computation. Thanks to IPSDK, you can just use very time-consuming, very precise algorithms without impacting your process. This is a slide that I do like because with this slide, you can really see where we're coming from and where we want to go and how we arrived at that position. 12 years ago, creation of the company, and it's been 2 or 3 full years of development to propose the first version of the library. At that time, there was no graphical user interface that was really dedicated to developers or to be distributed on clusters. And it was already using the de facto, standards de facto of computation, Python and C++, and also usable on Windows and Linux. That was the foundations, the base part of IPSDK. And 6 years ago, and since the last 6 years, a lot of things were improved. So now we have a graphical user interface, which permits, and you will see that just later, in a fast way, the way of doing some automatic Python script generation, the way of generating scripts without writing single code lines. We integrated also machine learning, AI implementations for both segmentation, which will be part of the topic today, but also for object classification, when you want at the end to get a report and saying, okay, how many number of objects from this side or this part. And beginning of last year, we integrated a 3D viewer, which now permits us to make some volume rendering. We can also extract meshes. We can also simplify the meshes, so doing the remeshing. So we can also make some surface rendering. We can make some movie makers. So we have a movie maker which will permit you to generate nice movies. And since this year, we also propose plugins. But before we jump in the pure porosity, what's the interest of getting a plugin? What's the meaning of a plugin? In most of the software of our competitors, you will get modules. So they propose a basic package and they propose modules. But then you have to purchase all the modules, even though you may be using that only once a year or twice a year maybe. But that's the main question. Is it any return on investment? It is interesting to pay for something that you will barely use. Another thing, when you purchase a module, you have also extra cost on the maintenance. So that's another axis, still about money. And if you didn't purchase your module from the beginning, and if you have a new need that arrives 2 or 3 years after purchasing the license, if you have this need, the supplier, the software editor will tell you, okay, you have to purchase a module. So how can you find a budget 2 or 3 years after purchasing the initial license? So that's really a main problem, both for academics or for industry right now, because it's budgets is very complex. But well, let's imagine you purchase the module from the beginning, or you could acquire because you found some extra budget 2 or 3 years after. When you get the module, it's a module that was imagined, developed, pre-developed by someone in an office, but not directly on your office. And you may just have a module that works quite well, but not exactly for your own application. How can you fine-tune this module if it was not imagined at the beginning? So we've been traveling a lot during the year 2024, so last year, discussing with our users, making workshops, making user meetings, trying to understand how our users were using IPSDK and what was the feedback of the usage. And it was said, well, IPSDK is good, but we need to be experts in image processing to be able to use it properly. So that made us decide that we don't oblige you to be an image analysis expert to achieve great results, to achieve great science. So we developed these modules, and we decided that also in terms of money, because that was also one of the complaints, saying, well, we don't want to be obliged to pay every time that we need a module. So that's when we decided also that all the plugins are available with IPSDK package. So you don't need to purchase that, it's part of the package. And if you want to change it, we propose you a plugin, but you can optimize, change, modify, integrate this plugin on demand. You can do that by yourself, or you can ask us to do that. And so far we have different type of plugins, which will be some of them that we will be discussing today. Porosity analysis, Pore Network Modeling for complex networks, also representative elementary volume estimation. So that's another module which I will be presenting you just after. But we also have the grain sizing, or it can also be called particle size distribution, a fiber module, battery analysis. So we have all these plugins, and in order not to make too much pollution, visual pollution in the graphical user interface, you can just define which ones you want to activate or not on your software. But let's start by a plugin that is very versatile and that is of interest for any type of application. Porosity, okay, but also for other type of material characterization or pore size distribution, which is representative elementary volume estimation. That's a quite common question, is how can I define, must I analyze all my data set, the full data set, or can I just define a region of interest that will be representative of my full data set? Basically, so REV, representative elementary volume, which you can also see in the literature called RVE. But this question is for any type of users. Trying to find the minimal size of a data set that will be representative to the result. So defining that, but without impacting the final result. And also taking into account that you don't have always the biggest machine in the world. So you want to save time of computation. If you make a too big computation, it will take a lot of time, but it also needs a lot of hardware requirements. So that's the idea, which is a proper size, which will be the correct one. And this one could be either because you didn't start making the acquisition, so you have just one and you want to optimize your acquisition. Should you make a 4K acquisition or should you make only a 1K acquisition? And if you already have some data sets pre-acquired, like if you went to ESRF, for instance, or any synchrotron, should you analyze a 1 terabyte data set, or maybe a 100 megabyte would be enough? So that's the two questions with the same type of need. So the idea of the representative elementary volume is you compute a microstructure parameter and you will make some blocks of the same size, makes computation of this parameter on several blocks, extract a variability, and then you will increase this block size, and we do that again and again and again. And then you define a tolerance that will be acceptable for you. And if the variability is below this tolerance, then you arrive at the volume size that is considered as large enough to be representative. So, let's say in more classical words, smallest volume over which your measurement will be compliant with your tolerance and which will permit you to investigate material characterization or prepare some type of simulation if you have later on. So it already exists in open source solutions. So basically in open source, you take some random blocks, you make the computation, you increase the blocks, random blocks, once again, computation, and so on. But it gives you some instability in terms of the results, and it's not very easy to read when you are below your tolerance in terms of standard deviation. With IPSDK, as I told you, it's fast. So now, instead of making some random picking, instead of just getting something that may not be completely homogeneous in terms of metrics, we would just use the sliding block on the entire image. So it means that we will compute all the possible blocks through the dataset, extract a metric, increase the block size, extract metric, and so on. And that's what you can see on the right part of this image. So you will see that something that is very robust, very noise-free, and it's very easy to read. You can directly say, okay, the crossing line between the graph and the tolerance line will provide you the optimal dataset size. So easy graphical user interface where you define your initial volume. You can define the voxel size. You can define the smallest and the biggest block, so the targets, from where to where do I go, and then you define a step block. And you can say also, define your standard deviation, the tolerance actually. And you can see that it's very easy to read. Crossing line, it will give you directly the information. It's usable and it's interesting for any type of applications. And here you can see that it can be used for battery analysis. You can do that for geomaterials. You can do that for rock models, and you can do that also for cements. So that's really of interest for any type of applications. How does it work? So you can get your image, so you get your label, your binary image, and you just need to say, okay, I have a 25 micron scale, XYZ, I mean voxel size, going from 25 to 200. My data set is a 500 cubic, and you can just run it, and you can see that it's very fast to make the computation. So we're making the sliding blocks along all the data set. And you can see directly that if you take something 100 voxel cubic, you will get something representative. So it means that, of course, if you take more than 100 voxel cubic, it will be even better in terms of precision, but you're the best fit between your tolerance and the size of computation and the size of the data set is here. So it means that you will optimize and magnify your analysis without impacting the time. Okay, so let's go back to the rest of the presentation. Let's speak now about porosity. Since we know exactly how to define the optimal dataset size, if you want to make some porosity analysis where you have isolated pores. So you can get an image like this one, a dataset like this one, where you want to extract and measure and quantify, analyze the porosities. So they are isolated pores. And what is interesting is to know where are they positioned, what's their size, what's their shape, the distance to the closest neighbor, or whatever other type of metrics that you are interested in. Previously, in IPSDK, you had to create by yourself the full package. So you had to create by yourself all the different steps, what I call the Legos, the Lego bricks. you want to, well, you will build your own application. So first you start denoising or enhancing your data set, and then you make some segmentation, and then you need to do some morphological operation. But you have to go through, even though you know the main chapters, you have to go through all these elements. And they, well, you really have to create everything by yourself. So after discussing with all our users, that was one of the main requests. Can we just make something much easy to use? And that's when we created that. And it's a step-by-step process. We will guide you. So you don't need to go through all the chapters. You just say, okay, first I need to make pre-processing. Do I need to do that or not? But at any time, just click on the icon and you will get a preview. Okay, so then once you have done your denoising or enhancing the data set, then you can go to the segmentation, which can be a simple threshold, threshold between two values that you will define manually, or it could be an OTSU, which is an automatic threshold based on the histogram peaks, splitting roughly the image in two at the middle of the peaks, okay? Or it can be also some smart segmentation, which is AI and machine learning. Just a few words about that, because it's important to know how it works. You will take, so this is a graphical user interface of IPSDK for the machine learning. So you will define the number of classes, 3 classes, background, grains, and intermediate class. You will define some features. So every green checkbox is one of the features that will be computed. You can also play, is it in 2D or in 3D, multiple resolution, full resolution, 50% resolution, and so on. And here you can also play with the neighborhood. 1, 2, 3, 4 is a distance that you want to take in account when you are classifying 1 pixel or 1 voxel. Then you will tag some pixels, like when we were kids and we were just drawing on the image. And automatically you will get a result, a segmentation result, which is good. But you can see that here you have the list of features that are sorted by importance. So you know exactly what's the weight, what's the importance of each feature to get my result. And some of them may not be useful. You may have some that are not useful at all or barely used on that, but they will be computed. So you can just remove features that are not used at all, 0%. And you can see here on the right side that Laplacian, high-pass, variance, and erosion were not used, so they are just removed out of the model, which will permit you, if you don't compute them, you will save memory and you will save time of computation. And then you can go on the main panel of IPSDK Explorer, and you can just call the model, and you get your result. And this model can be called directly in a Python script, which you can get directly. Still few words. So you have seen that you have one image, you apply your model, you get your a result image, and that's good. But in the middle, you have seen that we have plenty of features that can be computed. And quite easily, you can arrive between 10 and 100 intermediate features. So let's imagine that you have a 1 gigabyte data set. You will get a 1 gigabyte result. And if you have 100 intermediate features, you need a peak of 100 gigabyte of computation. If your machine is a 50 gigabyte, it will not be enough. So if you just apply it straightforward, your data set will be too big and you will just crash your machine. So we have a smart implementation which will say, okay, I need 100 gigabytes of computation. I only have 50 gigabytes in my machine. No problem. In that case, let's just split that and compute the first half, the first 50 gigabytes. I store my result. I will compute my second half. I store my result, and then I just need to stitch it. So IPSDK automatically will be able to adjust to the memory that is available on your workstation. And you will not have any more crash issues on that. But let's go back to the main topic, which was porosity analysis. You can make, so as I presented you can do manual threshold, automatic threshold, machine learning, but you can also create your own macro if you want, your own script. If you have your own script of segmentation, you can use it. I said that we can generate scripts without writing a single code line. You can just say, okay, I want to make my computation. I will make a node-su segmentation. Then I want to make some operations to remove all the small elements, and you can do that. And with different steps, you can just make a right click on the final image, generate complete script, and you will get directly the equivalent Python script, which is a clean one and which is very easy to read, one line, one operation. And you have all the imports here, so if you just want to call it from outside of IPSDK, everything is already available, everything is already ready for you to be called from any other one or any other place, or to integrate that in the porosity module. Okay, so then you can continue. Do you need to make some morphological operation? Do I need to make some filling holes, to make some smoothing operations? Separation. Are my porosities that I would like them to be isolated? Are they connected or not? If yes, we can use a watershed. We can use a classic watershed if all our porosities are roughly the same parameters in terms of size, in terms of circularity. If not, we have an implementation of an adaptive watershed that will automatically adjust to the size and the shape of your particles. This is a unique implementation that is only, as far as I know, only available in IPSDK. And if your porosities are already well isolated, and if you don't want to separate them, you can just go on the connected components. Then you can still make some post-processing. Do you want to remove the particles, the porosities that are touching the boundaries, the edges of your dataset? Yes, no. If you want to make pore size distribution, you need to apply it. If you want to make some density, don't apply it. And then you can continue removing two small shapes, two big shapes, so you can do all that. And finally, what's interesting is to extract metrics. So you can just define the metrics you're interested in. We have more than 100 metrics that are available. And you can also define, do you want an histogram or do you just want to get it in a spreadsheet? And to finish, you can also define if you want to save images at the end. Label image if you want later to redo some analysis. Color image if you want to share that with your colleagues or to integrate that in a report. But you can also make some hybrid views by merging the result on the original image as a color or as a contour. And once you have done that, you can save the settings and you can recall them, and you can just reapply it without re-going through all the steps. And once you press on this apply button, you will get all the results in terms of spreadsheet, histograms, cumulated histograms, whatever. And if you already have some predefined sieves or classes, you can also use that. And if you want to use this plugin as a template to create your own script, you can also just use this one and say, okay, this is the equivalent Python script corresponding to the setting, to the profile that I've just been using. And to get some more information, if you still have some questions, how to use that, what's each feature, you can just get the question mark here, and you will get automatically to the web page, to the documentation of how to use a plugin. Let's just see how it works directly in IPSDK Explorer. So you can just get your make it more relevant here. You can get your data set, which is a 3D data set. You can move through the different slices. And if I go, just clean a little, you can just say, okay, maybe I want to make some filtering. Okay, I can apply it, and you can see every time I will click on the icon, you will see a refresh here, and you will see the different steps. I want to make a binarization, so all the different elements. Let's go on a node suit to make it automatic. And you will get that, and you can see that it's done in the full 3D dataset. If you want then to make some morphological operation, maybe it's not relevant in that case, but let's go here. Adaptive watershed. We have some circles. Porosity is very circular, but we could imagine doing some things like they are not all the same size. We can apply an adaptive watershed. And automatically it will populate and you will see the result. So each particle is an individual label. And we can continue. I want to make some porosity analysis to get the pore size distribution. I can use a border kill. And then we can continue, so I will be very fast here, but you can go through all the elements. Here I can ask an image ratio, or I can just remove it. I can, I don't know, a form factor, inertia, neighborhood, for instance, distance to the neighbor, and we can just apply it. And you will get automatically an histogram for the volume 3D. Here it is, histogram volume 3D, and in my second screen, sorry, the metrics. So you will get all the information. One line, one pore, and one column will be one metric. So you can get the metrics that I was requesting. Let's just go here. Equivalent diameter. So you can get the equivalent diameter, you can get the volume, you can get the aspect ratio, the barycenter, everything is present here. And now, if you want to save it, you can just call it webinar, you can save it, and now I have my webinar entry that is here. I can close everything, and you can just apply it. And you will get your results as all the steps that we've been doing. So you just create that, you get your profile. Here they are, the results. And here it is. And if you want to get the equivalent Python script, you can get it here. So that's exactly the steps that I've been doing. So the different filtering, the different morphologies, the metrics that I was interested in. And you can also use it as a batch. So you can define you can define the folder where all your images are, and you can see that they are just computed. So they are running. Computing the second one. And in the meantime, I will show you the results where they are stored. Okay, computation is okay. And now you can see that on the porosity batch, I have now a new my results, which are one result per data set and a merge analysis. So I had only 2 images here. Okay. Another thing that we can do is about 3D. I mentioned you about the 3D, and we can make, so visualize the data sets in 3D. We can analyze also the results. And we can also do maybe something like show you how the Movie Maker works. But basically, you go with your data set. You can create a scene. Here it is. I can go. I can create my small scenario. Okay. And then I can do something like that. For instance, my porosities are appearing, and then I just change my opacity, and I can go very far. And then you can just replay your scenario, and it's very easy to use, and you can combine several types of images. You can combine and create very easily your script, which you can save just after and say, okay, I want to save my movie as, and you have several formats for saving it. Okay, let's go back to the presentation. And now you can also get Pore Network Modeling. If you're not interested in isolated pores, but in a real tortuous or a connection of the pores, we have also a plugin. If you have this type of data set, which are rocks, and you can see some porosities between the grains, you can just use exactly the same strategy. So you can see that it looks like the same graphical user interface, or same philosophy. You can make some pre-processing, you can make some binarization so that you can get something like that. And then the idea is to modelize each cavity as a sphere. And that's the kind of displays that you can get. So you will get one sphere per cavity and one stick, one for each pore throat, each connection between two cavities. There is some codes of display. The size of the sphere will be related to the volume of the cavity, and the color of the sphere will be related to the maximum fitting sphere inside the cavity, which gives you some information about how big the cavity and how thick the cavity. And then you have the connection of the pore throats exactly the same way, so to know that cavity 1 is connected to cavity 2 and so on. So you can continue through all the different steps that I will not just redo again. But you can say, I want to get individual pore measurements, and you can get also the throats, the connections, length, width, and so on, surface, whatever, which will permit you to get an analysis on pores and on connections. But you can continue once you have done that. It's not only for visualization, or maybe you want to go one step further. Maybe you are interested in permeability or tortuosity, and we have some modules, some scripts, not modules, but scripts, where we have some geodesic tortuosity or M tortuosity. How does it work? Basically, you go through your material, and you can define the shortest path through the pores, the pore network, to define the shortest path. So you can go from blue to red, and you will define that. And we have another way of doing that, which is the M tortuosity, which we developed with IFP Energie Nouvelle, which basically you will go from your binary mask, and you will define several seeds, and you will compute the mean tortuosity going through the material. To conclude, because we are out of the time yet, basically, so we propose with IPSDK Explorer 3 plugins, so no extra budget needed. Everything is in the package. So as long as you have a version 4.1 and more, you will have access to these plugins. Representative elementary volume estimation, which is not only for porosity, but it's really for any type of analysis, is defining the optimal dataset size before acquisition to define the best acquisition settings, or after acquisition if you already have done your analysis. This will really permit you to minimize the time of computation and defining not needing to have the best workstation in the world to be able to make the computation. Porosity analysis, if you have individual porosities, isolated porosities, this is a plugin that is used for. So you can segment, you can measure, you can understand your pore size distribution. If you have, in the other hand, some interconnection between porosities, and you don't want to analyze only porosity per porosity, but really understand how the porosities are interconnected, there is a Pore Network Modelling Plugin, which will permit you to understand, measure, okay, but also to visualize and modelize complex porous networks. And if you still need some help, well, we are here to help you, and we can really share our expertise with you so that you can really focus on your own application. So that's the end of this presentation. Feel free to come back to us to let us know your feedback. Your feedback is very important because that's really what drives us with our roadmap. So we don't want to be developing useless things. We really want to be developing things that will be of interest for you. If you already have ideas about what could be interesting in the future, let us know. What could be the next plugin? So we already have in mind some plugins which will be focusing on the ring artifact removal or focusing on registration of data sets. But well, let us know. We will continue pushing on these plugin things because it's really, well, that's really an easy way to get results in a fast way. And then if it's needed, we can use that to make it more robust for your own application. Thank you for your time, and well, let's see you again in the next presentation and in some upcoming webinars. Bye-bye.